Alright, thank you for joining us today. We're learning how to use Agisoft Photoscan to create three-dimensional models from photos. There's a lot of different applications for this that are pretty cool. People are using Agisoft to map landscapes using drones. They're using it to map buildings, both exteriors and exteriors. Some people at FIT are interested in using Agisoft to create models of prosthetics. And then a lot of folks use it for video game design, either to create faces of different characters or to create the background scenery, different wild environments for different video games. And I'm using it to study coral reefs. So let's look at a couple of these different applications. Here's an example of somebody who's using Agisoft to map a landscape. So they come up with a pretty cool looking 3D model that they can then pan around. And this one is actually created from just 12 drone photos. You can see here where it says chunk, 12 cameras. We'll talk about that in a little bit. So it's a pretty impressive model that they ended up creating from just a couple photos taken with a drone. And obviously you could do a lot more with more photos. So that's landscape mapping. Here's an example of where people are using Agisoft to map an excavation site, an archaeological dig. So this one, let's see. So this is the building that they're scanning, and then they've got a dig site on part of it. You can see again pretty high resolution quality just from photos. So here they take you inside the building and they're looking at some interiors. We'll talk a little bit about how you would need to take photos if you were going to be looking at a building interior versus the exterior of the building or the object. But the detail that you can get from this is pretty impressive, and I imagine that they were probably combining this with some surveying techniques to get it to be this accurate. Alright, so that's an architectural or an archaeological application. And then we've got some pretty cool video game applications. So this is an example of a photo lab that folks have got set up where they're capturing images of someone's face as he makes different expressions. And you can imagine that would be really useful for any kind of animation or video game design. So they've got this array of DSLRs set up, and they're able to capture his face from all these different angles with the cameras and then build 3D models of his face. And the resolution that you can get out of it once you texture the model and everything is really pretty impressive, the amount of detail. So you can see the pores in his face, you can see how much he shaved today. It's actually pretty wild. So the applications for video games or anything else like that is pretty amazing, and a lot of people are using this for that. So we got a lot of different possible applications. Here at Florida Tech we're starting to use it to look at coral reefs. So typically when we study coral reefs, this is a general image that you might expect to see of somebody trying to document the state of a reef. And he's taking photos looking straight down on the reef. And this is good, but it documents the reef as a two-dimensional surface. And we know that that's not true of reefs. They're very complex three-dimensional surfaces. So there's probably a lot to be learned if we start looking at coral health, disease, changes in coral reef ecosystems by examining them in 3 dimensions. So here's an example of a 3D model I've been working on for a pretty structurally complex coral reef built of a lot of branching corals. And you can see now we're starting to be able to look at the reef in 3 dimensions. Obviously this is still a work in progress. There's a lot of holes in this model, but it's a start. So I'm going to take you through how to make a 3D model in Agisoft Photoscan using my work as an example. Obviously this would look a little bit different if you were doing it in something other than coral reefs. So over here, this is the Agisoft Photoscan setup. I've already got photos loaded into it, but if you didn't, you would be going into Workflow and Add Photos. And then you would navigate to whatever file your photos are in. Mine are in Reef Photos. I select all my photos and then I select the ones that are relevant. So if I have some extraneous photos that maybe I took just to keep track of data, I wouldn't put those in. So I would select them all and then just hit open. And then they come up here in my toolbar down here. So this is a series of, I think this one was close to, I don't know, maybe 200, 300 photos for this transect. And so that's the image capture, the first step, importing photos into Agisoft. But before we move on and do more stuff in Agisoft, let's think about what you need to do to get good images to use in Photoscan. So you're going to need to use a digital camera with at least 5 megapixels resolution, or preferably higher. I've seen some really nice models created with very expensive DSLRs, which I didn't have access to. Generally, when you're taking photos, you want to aim for about 70 to 80% overlap. That's what Agisoft recommends. And you want to avoid any major blind spots, because those will translate to big holes in your model at the end of the day. Especially when you're doing this maybe in the field like I am, you want to err on the side of taking too many photos rather than too few, because you can always, having too many photos is generally not going to be a problem, but it's hard to go back out into the field and get more. So here's a couple different ways that we need to think about taking photos depending upon the object that we're capturing. If we were going to try to capture an isolated object, so let's say maybe that you wanted to 3D scan something for 3D printing that you could hold in your hand, or maybe a statue outside that's too big for a 3D scanner, you would want to take photos around it, completely around the exterior, and you want to have a lot of overlap in those photos, which is what they're showing you here. If you just take a couple from a few different angles, you're going to end up with a lot of holes. So you probably have holes here where you don't have photos. So that's pretty simple. Now if you were going to photograph a facade, or this would be the same thing if you were doing any kind of aerial imagery, you want to take a bunch of photos in a line that are overlapping, as opposed to standing at one point away from whatever it is that you're trying to photograph and changing the angle of the camera. That's going to make it really hard for the program to connect the photos. So you definitely want to take them overlapping, like so. And this is applicable to what I was doing with coral reefs. We were just photographing them down from the top instead of from the side. All right, then if you were going to do a building interior, you're going to want to walk around the perimeter of the room and photograph across to the other side in an overlapping fashion. If you were to stand maybe at different points in the room or in the center of the room, and again, change that angle of the camera, you're not going to get good results from this program. So that's a couple different things to consider. Depending upon what you're photographing, you might need to take a slightly different approach to how you take your photos. In my case, I was on scuba taking photos underwater. This transect was actually pretty shallow. You can see it was close to the surface. And so it's a 10-meter long transect, and I'm just pointing the camera straight down and shooting with as much overlap as I possibly can. And as you can imagine, it's kind of hard to control underwater precisely how much overlap you're getting, because you're always kind of moving. So that was tough, and pretty much I was just clicking away as fast as I could. I've heard of people taking GoPros and just putting them on a burst setting so that they get really a bunch of photos. I did it manually. Could be done a lot of different ways. For my 10-meter transects, I was typically taking about 300 or more photos, so that gives you a sense of just how much you really need to get good photographs. And also because I was really interested in capturing some very structurally complex features. You can see these corals stick up quite a bit from the bottom. I took photos from different angles. So I actually swam back and forth on this transect about 7 times and took overlapping photos from a variety of different angles. The trick is just to make sure that they're all overlapping with each other. You can't, start taking photos and then run over to the other side of whatever it is that you're photographing and start again, because it'll be hard for the program to put it together. It's got to be continuous. All right. So, photo alignment. So I told you how to import your photos into Agisoft Photoscan. We go into workflow and add photos. Once we've got them in here, it helps if we can give the program some information about control points that we're aware of. That's going to be a really useful thing to do. So we're going to want to go through and mark on each photo. Let me pull this down so that you can see it. Where points are. Known points. So, for example, on my transects, I put down these ground control point markers, and I surveyed with a transect tape in between them to know exactly what the distance and bearing was between each one. And that allowed me to create a local coordinate system so that I could say, okay, point 2 over here, you can see the x coordinate for it is 3.75 meters, the y is 0, z, which would be depth. They were all pretty much on the same level. So I make a local coordinate system, and then I have to go through each one of these photos manually and tell the program where the points are. And the really cool thing is once you tell it a couple, it can kind of start figuring it out on its own. And eventually it'll fill in the rest for you, which is pretty neat. so that speeds things up considerably. So I went through and marked all those different photos. Another really important step, which you should probably actually do before that, is assess image quality, because it might be that you need to remove some photos if they came out blurred. So what you want to do is go in to your photos. You can put them into this details mode, right-click on a photo and say estimate image quality. It'll ask you if you want to do it for just that photo or all of the cameras. Cameras is referring to photos, so I'm going to say all cameras. And then if I hit OK right now, what it would do is come up with this analysis right here that shows the quality of the different images. And I can sort that. My best image quality was about 0.76. My worst is 0.51. As long as you're not below 0.5, you can keep that image in there. But if you were, what you would want to do is click on this red thing and it'll disable that camera. And so then you won't have to worry about it messing up your model because it was blurred or something. So we estimate our image quality, we set our control points, and then the next step is going to be to align the photos. So we would go into workflow, hit align photos, and we've got a couple different options here when we are aligning the photos. We can pick how accurate we want things to be. I usually leave it on the highest setting. We can pick pair pre-selection or not. I usually leave it as generic. And then here we can pick a key point limit and a tie point limit. And I've always left these at 40,000 and 4,000, but you could read up on what's best to do for whatever you're looking at. So those are our alignment parameters. So we would go into workflow, align photos, select those parameters, and then click OK. And then the program goes through and aligns all these photos. So you're going to see here where it's got a green check mark, that was a photo that it was able to align. So I've got a pretty good alignment rate here. I'm really only missing a couple of photos that didn't show up, that it wasn't able to find a place for. So once the photos are aligned, the result is a sparse point cloud. And that's what you're seeing right here. So this is a collection of points that it's created from the different photo surfaces. You can see my ground control points in there. Here's my point number 2. So that's the first step, is the sparse point cloud. And you could use this if it was enough for you. For most people it's probably not going to be, but you do have export options for that sparse point cloud. Our next step is going to be to create the dense point cloud. And so here, the first thing that we're going to want to do is decide how much of the model is useful to work with. And we're going to set the bounding box around that area of the model that we want to focus on. So I go up here to this little blue button, and that's my bounding box. And then I can start playing with how much of the model I want to focus on to create a dense point cloud. This might be useful to you if maybe you're doing something that's pretty computationally expensive, you've got a lot of photos in there, and you really just want to look at a small area that's critical to save some time. You can set that bounding box and only look at one region. Another thing that we're going to need to do is remove any out-of-place points that we find. So you can see sometimes there's little points floating around here. There's actually a lot more when you start off. I've already edited this one, but you can get points way, way, way out. The bounding box will deal with most of that for you, but you can go in and select points that you feel are inaccurate, and then you can actually delete them with this little X button. So I could select any portion of this that I didn't want to include and delete it. So you want to spend some time cleaning up your sparse point cloud before building the dense cloud. And then once you've got your bounding box set and you're happy with all the points in your sparse cloud, you would go to workflow and build dense cloud. And here again you've got a couple different build parameter options. We can go and change the quality. I usually leave it at high. I think if you did ultra high, you'd be waiting a very long time for this to finish unless you were working with a small object and a small number of photos. You can also adjust the depth filtering. This is a pretty cool feature. So if we select aggressive depth filtering, it's going to remove a lot of the points that it feels are extraneous, and that could lose us maybe some structural complexity. You might get a more overly smoothed image, but it's going to save a lot of time. If you go with this mild depth filtering, you're going to come up with a much more complicated structure, a lot more details. So it's kind of about assessing how much noise you need to remove from your point cloud, and you can play with it. Usually I leave the depth filtering on mild because I want to get as detailed of an image as possible. And then I would hit OK, and it would build the dense cloud. That takes quite a while, so I'm not going to do it here in front of you guys. But this is what it looks like. So here you go, big change from our sparse point cloud. Now we can see a lot of detail. This is a fun setting or stage to play with. So here you go, I'm going to zoom way in on one of these coral colonies for you. And you can see just how many points are making up this model, and it looks pretty good. If you've ever seen a coral before, you know that they've got these really complicated structures on them, and it's actually doing a really good job of getting those little details. So that's pretty cool. So that's our dense point cloud. And we could export this, or we can continue moving on and we can build a mesh. So that would be our next step, would be to create a 3D mesh out of this and actually have a true three-dimensional model. So here you go. The next step in the workflow would be the build mesh category. Again, before we go there, we're going to want to remove any points that we feel are out of place. That's exceptionally important here because building a mesh is really computationally expensive. It's going to take a lot of time. So if I was going to build a mesh around this model, I would probably want to take out little bits like this. And again, I could select them with this tool and remove whatever I want to, and just hit this delete button to get rid of it. So once I've removed any out-of-place points, I can adjust my bounding box again. Typically when I'm building a mesh with these very large models that are built of, like I said, about 300 photos and cover 10 meters of area, I restrict the bounding box considerably, and I try to work with just a couple meters of space at a time, because otherwise either the program crashes or I'm going to be sitting here all day. So here I might select just that area to build my mesh with my bounding box. So once we've selected the area that we want to build a mesh on, we go into Workflow, Build Mesh. It's going to analyze the dense cloud, and then it's going to offer you some options. So we can pick the surface type. They give you the options of arbitrary or height field. I've read that height field is better if you're working with, I think, like aerial photos. I'm going to stick with arbitrary. We can use different source data. We could use the sparse cloud or the dense cloud. If you wanted to just make a real quick mesh, you might want to use the sparse cloud because it might take less time. And then you can pick the number of polygons that it's going to create. So you can see if I went with the high polygon option, I would get 7 million, and that takes a really long time. So I've actually modified it here to even less than their lowest option, to only about 10,000. You can also play with interpolation. Enable or disable interpolation between points. Alright, so those are our different settings there. So we would select them and then hit OK, and then it's going to build us a mesh. And after the mesh is built, it looks something like this. So, oh no, sorry, this is still the dense point cloud. After the mesh is built, it looks like this. So this is just one small section that I chose to build the mesh on. I'm going to move this bounding box so it's a little bit less distracting. So if we zoom in here, that's the mesh. And so I'm looking at it now in a kind of shaded format. You can see that there's holes underneath the coral colonies because I wasn't able to photograph their undersides. That's kind of a limitation of this in underwater applications. But it's still a lot better than a 2D photo. So that's a shaded mesh. Then we've also got this kind of just grayed out version for looking at it. You can look at a wireframe. So if I zoom in here, I can see all those 10,000 polygons as they're lined up, and you can see the holes underneath. All right, so that's the mesh. The next step is texturing. So we would go into Workflow, Build Texture, and again, we've got a couple different options here. I always select, for my mapping mode, I always select Adaptive Orthophoto. That really depends upon what you're photographing. You could pick spherical. If you were just trying to create texture from a single photo, which you can also do in Agisoft, you could pick single camera, orthophoto. It really depends upon what type of structure you're looking at. And then your blending mode, you can change to. So that's going to be how it blends colors between points. Mosaic is the default, but you can also blend based upon the maximum intensity of the points, the minimum intensity of the points. Let's see. We can enable hole filling. I do that. As you've seen, there's a lot of holes in my model, so I want all the help that I can get with it. So then we would build texture. And once we build the texture, if you remember, our shaded mesh looked kind of like this. So you can see it's pretty rough. We don't really look like coral colonies there. When we add the texture to it, you can see a lot more detail. So if you're used to looking at corals, you can see that these are like actually individual kind of polyp structures for the individual coral animal that we can see here, which is pretty cool from a biology perspective. But anyways, a lot more visual detail once you build in your texture. And that's the final step. So once you've got your textured mesh, you've got a bunch of different export options. So this is our full 3D model, and if we wanted to export it, we could go to File, Export Model, and we would have a variety of different file options. We could do wavefront.obj, we could export it as Collada, you could export it as Autodesk if you wanted to use it in Autodesk later. If you were doing something topographic, Google Earth KMZ could be a good option if you wanted to use it in Google Earth. So lots of different export formats for the 3D model. We can also export just the point cloud. So we can go to Export Points. That's weird, that didn't come up right. Okay, here you go, Export Points. And we've got a number of different formats here too. Again, wavefront.obj, we've got PLY format, XYZ point cloud, LAZ. There's a special Agisoft format. So that would depend upon your application and what you need to do with it for your own analysis. So that's how we create 3D models in Agisoft. What will you create with Agisoft Photoscan?